Hello again. All right. So 2C's and focus on what we call function notation and evaluating functions. This is one of the most important lessons you will have in Algebra 1, just because it's going to be so heavily used in, say, geometry, Algebra 2, pre-calc, calculus, statistics, chemistry, physics. Like it's going to be used in pretty much any STEM class. So a big idea of function notation is it's going to be used for what we call interpolation and extrapolation. So whenever I say interpolating or extrapolating, it's really going to be looking at data from within a specified boundary or outside of a specified boundary. So function notation really helps us find patterns and make conjectures, and it's a lot of the hypothetical kind of side of mathematics. So just to kind of dive into kind of the shallow end of it. So we are going to be given a function, and a lot of the times we're going to say, let's give it a name. So kind of like when you get a pet, you want to give it a name. So in this case, I got a little pet here, 2x plus 1. I'm going to name it f of x. So same idea. So the way that you say this is, just as before, f of x. So you can give many different functions many different names. And the reason we have this also is because whenever we're looking at data and we're looking at multiple functions, we have to be able to distinguish and identify specific ones. So I could also say, let's look at a function, say g of x, or let's look at a function, say h of x, or k of x, or b of x. Or you could even like mix up the variables. So you could even say h of t. So I know, let's look at n. H of t is going to be used in a later lesson for height with respect to time. So you could use any sort of different combinations of letters, but I will say f of x is the prominent and most common one. Okay, so what this first problem here is saying is I am given f of 5. That's exactly how you would say it, f of 5. So what this means is this x value is equal to 5. So if I have, say, f of x, and it's equal to 2x plus 1, I am going to take that 5, and I'm going to sub it in for my x values. So down here, what I'm going to do is instead of those x values, now I'm going to write 5. Okay, so I have f of 5 equal to 2 times 5, which is 10, plus 1, which is equal to 11. Okay. So we're given some x value, and our result is actually our y value. So if we even wanted to, we could also rewrite this as a coordinate. So I would rewrite it as 5, 11. Okay. So if you ever see those 3 dots written like this, kind of like a triangle, it just means therefore. Just FYI. Okay, so same idea here. Now we have f of negative 3. So I have f of x equals 2x plus 1. So now if I want to write f of negative 3, f of negative 3 equals 2 parentheses negative 3 plus 1. So you're going to sub in that number that they give us inside the parentheses. You're going to sub that for all of the indicated variables. So in this case, now I'm going to solve the right side of the equal sign. So I'm going to leave f of negative 3 on the left side. I'm going to leave that alone. So I have f of negative 3 equals, so 2 times negative 3 gives you negative 6 plus 1. So this is f of negative 3 equals negative 5. So that's what we're looking for. So therefore, negative 3, 5. That would be your coordinate. Okay, so I'm not really requiring the coordinates right now, but just for future reference, that's what it would be as a coordinate. All right, so I would say pause here, try this one on your own. So if I plug in 0, so you have f of 0 equals 2 times 0 plus 1. So this would be 0 plus 1, which would be f of 0 equals 1. And as a coordinate, 0, comma 1. Okay. So that's kind of the main basis of it. So now if we kind of step it up a notch, our functions can get as advanced as we possibly want them to. So we have a squared function over here of degree 2. We have a linear function, 3x plus 7, and then we have another linear function here, 10 minus x. So each one of these has a specific name. So just like mentioned before, we could be dealing with more than one. So in order to identify a specific function, we have to look at the specific names. So we have f of x, g of x, and h of x. Okay. So looking here, we have f of 3 plus g of 4. So we're only going to use f and g. So that means we don't even care about h right here. We only want those first two. Okay. So for f of 3, so what I'm going to do first is I want to find those specific values on the side first. So I'm going to do f of 3. That's going to be equal to, so 3 squared plus 1. So f of 3 equal to 3 squared, which is 3 times 3, which is 9, plus 1. So f of 3 is equal to 10. All right, so now I need to find g of 4. So I'm going to go to my g function and plug in 4. So I have g of 4. So 3 times 4 plus 7. So 3 times 4 gives you 12. Then plus 7, which means g of 4 is going to be 19. Okay. So now we want to find f of 3 plus g of 4. So the way I'm going to write this, so therefore, f of 3 plus g of 4 is equal to 10 plus 19. So f of 3 plus g of 4 is equal to 29. So we technically want this whole thing as our answer. Okay. So notationally, yes, I could understand if you just write 29. However, we have to be very specific in our answers, so we have to include the actual notation in the answer as well. Okay. So for this next one, now we have h of negative 3 minus f of 2. All right, so let's get rid of these. Actually, no, let's keep that. So once again, I'm going to do all the actual individual values on the side. So h of negative 3. So now I want 10 minus x. So 10 minus negative 3. Now be careful here, because when you subtract a negative, remember, that turns into plus a positive. So that's 10 plus 3. So we're going to have h of negative 3 equals 13. All right, so now we need to find f of 2. So f of 2 is going to be 2 squared plus 1. So it's going to be 4 plus 1. So f of 2 is equal to 5. So remember, now I'm going to kind of write everything together. So therefore, h of negative 3 minus f of 2 is going to be equal, so I want to do 13 minus 5. So h of negative 3 minus f of 2 is equal to 8. That is a weird 8, but it's okay. It has a great personality. Okay. So, and same idea with this very last one over here. So we have f of 5 plus g of 3 minus h of 8. Right. So as you can probably tell, these can get pretty tedious and kind of long. So one thing to note, these are what I call domino problems. So if you mess up at the very beginning, like if you mess up f of 5, then the rest of this is going to be wrong. So you've got to be very careful when you are starting off. So you could do g of 3 and h of 8 perfectly well, but if you mess up here, the whole thing's going to fall apart. So you've got to be careful. So start with f of 5. So just to double check. So f of x is the x squared plus 1. So I'm going to have 5 squared plus 1. So 5 squared is 5 times 5, which is 25, plus 1. So f of 5 is going to be 26. All right, so now let's find g of 3. So g of 3, now we're looking at 3x plus 7. So 3 times 3 plus 7. So 3 times 3 is 9 plus 7, which gives you 16. And last but not least, then we have h of 8. So h of 8 is going to be 10 minus 8. So h of 8 is going to be 2. Okay, so I'm going to write this off to the side. So therefore, f of 5 plus g of 3 minus h of 8. So this is going to be equal to. So here's another thing I really like about technology, especially using the white marker. Go over this to give yourself more room. Just be careful when you're erasing. Okay, so f of 5. So I'm going to have 26 plus 16 minus 2. Okay. So f of 5 plus g of 3 minus h of 8 is going to equal, so 26 plus 16 is going to be 42, minus 2 is going to give you 40. Boom. Okay, so I suggest you do everything separate, because here's the thing. You technically could combine everything and do this plus this minus this. Nope, not plus. This would be minus. So here's the thing. I strongly believe you're much more prone to making mistakes when you have everything jumbled together. So I highly suggest you just write it out separately. However, if you do want to write it out all together like that, more power to you, go for it. It's up to you. Okay. So now this next part, now this is actually finding the input when given the output. So here's the thing. Typically above, I gave you the x value. Now in this case, I'm actually giving you the y value. So up here, if I give you the x value, so here, I'll write this at the top, just as a general summary. So let's say I give you f of 3. So what that means is you plug in 3. However, let's say I give you f of x equals 3. So that is completely different. So in this case, you want to set your equation equal to 3. So set equal to 3 and solve. There's a bug on my iPad. Okay. Oh, probably shouldn't keep writing. And solve for x, or whatever the indicated variable is. Okay, so in this case, I have f of x, and it's going to be equal to 23. So I'm going to take my f of x function over here, so negative 3x plus 5. So those are the same thing. So I'm just going to rewrite f of x as negative 3x, yeah, negative 3x plus 5. And then I'm going to set that equal to 23. And now I just want to solve for x. So this is back to unit 1 when you're solving equations. So follow the same ideas, so inverse operations. So negative 3x equals 18. Divide. So x equals negative 6. Okay. So remember, we're given the y, so we want to find the x. So you don't necessarily have to write some fancy function notation for these. It's just an x equals. All right, so same idea over here. Okay, so g of x equals negative 10. So I'm going to take my g of x function and I'm going to rewrite it. So I have x over 4 minus 2 equals negative 10. And I want to solve for x. So once again, go through the steps and add 2. So I have x over 4 equals negative 10 plus 2, which gives you negative 8. So I will say, those of you that kind of get in a rush, this is where those mistakes start happening, because I see a lot of people messing that up. I see a lot of people writing 12. Okay, then here, multiply by 4. So you're going to have x equals negative 8 times 4, which gives you negative, that's not a 3, negative 32. All right. All right, so I would say pause here, try that last one on your own. So h of x, this is equal to x plus 1. We're setting it equal to 0. So this should be the easy one. So subtract 1, x equals negative 1. Okay. All right, so that's kind of the basics of it. All right, so now we're going to kind of step it up a bit. So we're going to kind of bring back some of the inequality stuff, as you can see from number 10. Then we have some proportions like number 12, and then some more intense problems like number 9. So there's a lot of things that we can do with these. Okay. Especially like number 8, like you're going to see it's a lot. All right, so we're going to start off just from the top, just from the general idea. So h of 7. So you want to find your h of x function, and you're going to plug in 7. Okay, so we're actually here with the way it is written, you can actually get away with doing this. So 7 plus 3 divided by 5, which then gives you 10 over 5, which simplifies to 2. So h of 7, so therefore h of 7 equals 2. Boom. Okay, g of negative 6, so negative 1/2, parentheses, negative 6, and minus 4. So when I multiply negative 1/2 and negative 6, you're going to get positive 3 minus 4, which gives you negative 1. Therefore, g of negative 6 equal to negative 1. All right, number 3. Now in this case, now we're given the y value. So this is the set equal to. So really look to see, are we given the value inside the parentheses or outside the parentheses? If it's inside, it's a plug-in. If it's outside, it's a set equal to. So, hello. All right, anyways, my highlight went away. There we go. All right, so I'm using f of x, so 2x plus 1, and that's going to be equal to 15. All right, so in this case, you're following your inverse operations. So minus 1, minus 1. So 2x equals 14. Divide by 2. So x is equal to 7. Okay. All right, now we have j of 0. So kind of ask yourself, is this a plug-in or a set equal to? Well, it's inside the parentheses, so plug in. Inside the parentheses, plug in. So kind of make that conjecture. So I'm going to use J, which is over there. So this is kind of the tricky one. It's just equal to 4. So it's just 4. So the thing is with this one, let's just say I draw a graph. This will make more sense if I draw a graph. Okay, so J of X equals 4. What this is saying is for every X value, the Y value will always be 4. So it's a horizontal line on a graph. So no matter where I plug in, it will always be 4. So like this could be like -5, 4. This would be, say, 5, 4. Well, at 0, this would be 0, 4. So no matter what the X value is, it's always going to be 4 as your corresponding Y value. Okay. So therefore, J of 0 is equal to 4. I almost erased it instead of highlighting it. Okay. I kind of wrote out the explanation on the note key, so if you want a little bit more of a written explanation, I would definitely go see how that one's written for you. Okay, so now we have G of 0 minus J of -2. So J, not J, G. So G of 0, so I'm going to write these out separately. So -1/2 times 0, is it -4? Yep. So G of 0 equals 0 minus 4. So G of 0 is equal to -4. And just as mentioned before, with J, it's always just -4, or not -4. It's always +4. So J -2 is just equal to 4. So now I want to subtract those. So therefore, make sure you get the order in the correct way. So J of -2, so equals -4 minus 4, which is equal to -8. So therefore, G of 0 minus J of -2 is equal to -8. So you don't have to write the therefore every time, it's just a habit for me. Okay, so H of X equals 0. So ask yourself, is this a plug-in or is this set equal to? Everything's fine, I don't know what just happened. Okay, so H of X equals 0, so because it's on the outside, this is a set equal to. So I'm going to take my H of X function, so X plus 3. No, I didn't. Okay. Thought I messed up somewhere. X plus 3 over 5, and that equals 0. So I want to solve for X. So the first thing, I'm going to multiply by 5. So that's gone, that's gone. So we have X plus 3 equals 0 times 5, which is 0. And I'm going to subtract 3. So X equals -3. All right. Okay, so F of -3, so ask yourself, is this a plug-in or a set equal to? Well, notice how it's inside the parentheses, so this is a plug-in. So this is going to be 2 times -3 plus 1. Yep. So this is going to be -6 plus 1, which gives you -5. So F of -3 is equal to -5. Oh my gosh, that's not straight. Everything's fine. All right, so now we're going to get into the little bit more complicated ones. So starting with number 8. All right, so what these are saying is I want to set F of X equal to G of X. So I'm going to find the values in which those two equations would be equal. So f of x is the same as 2x plus 1. G of x is the same as negative 1/2 x minus 4. Negative x minus 4. So now this is kind of going back to 1b when you're solving equations. All right, so you have a few different options to solve this. So personally, I would say get rid of that fraction. So because we're dividing by 2, what I'm going to do is I'm going to multiply everything by 2. So if you want to add over the negative 1/2 and then make that into a 5/2, you can. But I feel like this idea would probably be better for a lot of you, just so you can get rid of the fractions from the get-go. All right, so I'm going to distribute that 2. So you get 4x plus 2 equals negative 1x minus 2. Now I'm going to solve. So I'm going to move over the smaller variable. So I have 5x plus 2 equals negative 2. Subtract 2. So now I have 5x equals negative 4. Okay, so I'm going to bring this up here. So 5x equals negative 4. So now I'm going to divide both sides by 5. So x is equal to negative 4 fifths. So once again, just because you get a fraction as an answer, it doesn't mean it's wrong. Okay, number 9. All right. So h of negative 3, so I'm actually going to write this all in one area. Oh, I was until I saw what the actual equation was. Just kidding. Okay, so h of negative 3. So this is negative 3 plus 3 over 5, which is 0 over 5, which is equal to 0. And then we have g of negative 8. Where are you? There you are. So g of negative 8, which is negative 1/2 times negative 8 minus 4. So g of negative 8, so it's going to be 4 minus 4, which is equal to 0. So whenever I'm subbing in these values, so what I'm going to get is 0 over 0. Be very, very careful how you answer this. If you answer 0, wrong. If you answer 1, wrong. Your answer is undefined, all because you cannot divide by 0. If you ever have 0 in the denominator, it is undefined automatically. Doesn't matter what the top says. Okay, so this one is undefined, all because you cannot divide by 0. All right, now inequalities. H of x greater than or equal to f of x. So h of x, so we have x plus 3 over 5 greater than or equal to f of x, which if I remember right is 2x plus 1. Yes. All right, now you want to solve for x. All right, so I'm going to multiply both sides by 5. I'm going to put that in parentheses, so these would go. So you have x plus 3 greater than or equal to 10x plus 5. All right, so I'm going to move over the x. So I have 3 greater than or equal to 9x plus 5. Subtract 5. So you have negative 2 greater than or equal to 9x. Rewrite this up here. All right, so now I'm going to divide by 9. So I have negative 2 over 9 greater than or equal to x. Now here's the thing. We have the variable on the right side, so remember, the rule of LOL, letter on the left. So I'm going to flip it. So x less than or equal to -2/9. All right. All right, now we have g of 3/4. So now we're plugging in a fraction. So we have, of course, it would be, so -1/2 times 3/4 minus 4. All right, so whenever you're multiplying fractions, you multiply across. So -1 times 3 and 2 times 4. So I'm going to have -3 over 8 minus 4. All right, so this part is really just to kind of help improve your numerical literacy. So I want to be able to combine those values. So I have -3 over 8, and I want to be able to turn 4 into a number with a denominator of 8. So think about it. I can rewrite 4 as 4 over 1. So to go from 1 to 8, you multiply by 8. So that means I'm going to do the same thing to the 4 to get the new numerator value. So 4 times 8 gives you 32. So that's our new numerator. So now I can combine those into 1. So I'm going to do -3 minus 32, which gives you -35 over 8. So g of 3/4 oh no, everything's fine. Boom. Okay. Time for this nightmare. Okay. So I'm going to find h of 12. So h of 12 is going to be equal to 12 plus 3 divided by 5, which gives you 15 over 5, which gives you 3. So j of 6, if you remember, it's always going to be equal to 4. So this is 3. So now we just got to find f of 6. So f of 6 is equal to 2 times 6. Is it plus 1 or minus 1? Plus 1. Plus 1, which is 12 plus 1, which is 13. However, we want to take 1 away, so this is actually all 12. Okay, so now I'm going to rewrite this proportion, not equals. There we go. So we have 3 over 4. Oh my gosh. Equals x over 12. So simplify the proportion, solve. So we have 4x equals 3 times 12. So 4x equals 36. When you divide, you get 9. Okay. I would definitely say take a break here if you can. That was a lot. Or keep going. It's up to you. All right, so some word problems. Okay, so really interpreting what the data is telling you is going to be important for these. So a river has an initial height of 40 feet and is receding at a rate of 0.5 feet per day. The height of the river is a function of the number of days. So you want to write an equation to model this scenario. So when I say write an equation, it's going to be in slope-intercept form. So y equals mx plus b. So your m value, which represents your slope, this is going to be your rate. Okay. And then your b value is always going to represent the initial amount. Okay. So in this case, our rate is, it's receding at a rate of 0.5 feet, so half a foot. So because it's receding, it's actually a negative. And we're starting off with 40 feet. So it's starting off at 40 feet and it's slowly going down. So that's our equation. So now we want to determine, is this scenario continuous or discrete? So because we're talking about volume and time, you can have a part of both of them. So this is continuous. So you. All right, so what is the independent and dependent variables? So whenever I'm asking for the independent and dependent, so the independent is asking what is the x value, and dependent is always asking what is the y value. So in this case, the independent is going to be time, and then the dependent is going to be volume. So in this case, I would say independent. So time in terms of, I want to say it was days. Yes. And the dependent is going to be volume. Is it? Yeah, it's in terms of feet. So in this case, it's going to be in terms of cubic feet. Okay, so this would be your independent and dependent. Okay, so what's the height of the river after 12 days? So here's the thing. This is where you really want to use your independent and dependent parts to your advantage. So part C is really going to come in handy. So they're giving us 12 days. Well, that represents time. So which means they give us an X value, which means they want you to find the height. Oh, dependent's not volume, it's height. Silly old me. Je suis désolé. I am sorry. Okay. So back to the height. So in this case, they want us to find f of 12 is essentially what they're saying. So now I'm going to use that function from A to find f of 12. So f of 12 is equal to negative 1/2 times 12 plus 40. So f of 12 equals negative 6 plus 40. So f of 12 is equal to 34 feet. Okay. And now it's going to ask, after how many days will the river be completely dried up? So when I say completely dried up, this is saying when the height is going to be 0. So in this case, they're giving us a y value and they want us to find an x value. So what that means is now I want to find when is that function going to be equal to 0. So I'm going to subtract 40. So negative 1/2 x equals negative 40. So now I'm going to multiply by negative 2. So negative 2 here, that go away. So I have a positive x equals positive 80. So after 80 days, the river will be completely dried up. So that's what, 2.5 months, 2.5-ish months. Okie dokie. Number 2. So Anna sells cookies to raise money for her softball team. So the supplies to make cookies cost $45 and she sells the cookies for 50 cents each. So the profit she earns is a function of the number of cookies she sells. All right, so kind of think back to our inequalities. So the supplies cost. So this right here is going to be an expense, which means this is going to be a negative 45. So it's only a one-time thing. However, she sells the cookies for 50 cents each. So this is going to be a profit. So plus 50 cents per cookie. So anytime it says each, that's going to tell you it's going to be written with the variable. All right, so now I want to write the equation. So same as before, it's going to be written in y equals mx plus b. So in this case, 50 cents each cookie, that's the rate. So I'm going to have y equals 50 cents per cookie. And then she has the expense of $45 for the equipment. No supplies. So this would be your function. So is the scenario continuous or discrete? So in this case, because we're talking about selling cookies, these are physical objects, which means this is discrete. Okay. Physical objects are discrete. So you cannot sell half of a cookie. I mean, ideally you could, but in the real world, you don't go to like a store and like, can I have half of a cookie? No. All right. Let's see if I can get this one right. So the independent and dependent variables. So in this case, the independent is going to be the number of cookies sold. And your dependent is going to be the profit. So if you need a little bit of a hint as to what the independent and dependent are, look at your initial problem. So the profit she earns is a function of the number of cookies she sells. Those are your two variables. Okay. So now it wants to know what will her profit be after selling 150. So look back to your independent dependent. If I give you 150 cookies, did I give you an X or did I give you a Y? So remember, independent is your X, dependent is your Y. So I actually gave you an X value. So this means you need to find f of 150. Okay. I'm not a human calculator. Hello. Okay. So I'm going to find f of 150. So 0.5, so 50 cents for 150 cookies. You want to subtract half of 150 is 75 minus that, so 30. Just going to double check because you never know. Yay. Okay. So her profit is $30. All right, so now how many cookies does Anna have to sell to break even? So this is where my business background comes in. All right, so when I say break even, it means how many does she need to sell in order to not make a profit but not lose money? So what this means for break even is f of x equals 0. So for her profit per se to be literally equal to 0. Okay, so I have 0.50x minus 45. It's going to be equal to 0. So 0.50. I'm going to add 45 on both sides. All right, so 0.5 is the same as 1/2. So I can multiply both sides by 2. That's a parenthesis. That's 2. So then I will have x equals 45 times 2, which is equal to 90. So 90 cookies to break even. So if she sells 91, she made a profit. If she only sells 89, it's a loss. And they say you never use math in real life. Okay. So now, if Anna makes a profit of $250, how many cookies did she sell? So now I'm giving you a profit of $250, which means this is a set equal to. So 0.5 minus 45 equals 250. So if I add 45, so I have 0.50x equals 295. And if I double it, that'd be 590. So 590 cookies to make 250 bucks. Okay, so that's it for the word problems, thankfully, because I know those are brutal. Okay, so now for function notations from a graph. So these are kind of wonky at first if you've never seen or done this before, but I did write out kind of a general process to follow. So whether you're finding, whether you're given the x, finding the y, or whether you're given the y and you're finding the x. So I wrote out both processes. All right, so I'm gonna kind of walk you through just how to do the first few. So if I want to find f of -4, I'm given an x value and I want to find a y value. So what this means is because I'm given an x, I'm going to start on the x-axis. So I'm going to go to -4 on the x-axis. And I'm going to find where does the function cross -4. So if I go up here, so at -4, it crosses right there. So that corresponding y value is 2. So that means the corresponding y value would be 2. All right, now f of 0, so same idea. So I'm at 0. So notice how the function at 0, it crosses at 0. I didn't actually go anywhere. So it's just at the origin. Okay. All right, now at f of 2, so I'm given the x, so on the x-axis, I go to 2. So it crosses down here. So that corresponding y value is -2. All right. And then if I'm given -5, so I'm going to start over here at -5. So kind of similar to the origin, it crosses right there at 0. That corresponding y value is 0. Okay, so that's if you're given the x and you want to find the y. So now kind of the other way around. Now if we're given the y, we want to find the x. It's still a similar process, but instead of starting on the x-axis, now we're starting on the y-axis. Okay. So I have f of x equals -2. So now instead of starting on the x, I'm going to start on the y. So start at -2 on the y. That's a terrible circle. So I'm going to find this corresponding spot. And now I want to find that corresponding x value. So that's not a 2. That's a 2. So at 2 is when it hits -2. So x equals 2. All right. So f of x equals 0. So this one's not too bad, but this one has a bit of a weird solution. So you want to find any time it hits 0. So here's the thing. It hits 0 at 0, but also it hits it here at -5. So this one actually has 2 answers. So for it to equal 0, x equals -5 and x equals 0. Okay. All right, and now we want to find when it's equal to 4. So on the y-axis, I'm going to go up to 4. And I want to find, all right, so I'm going to go over here. I know it's a little bit off, but it's all right. So that corresponding value, that corresponding x value would be -2. So x is equal to -2.